Hey guys, today we'll see the concept in digital signal processing, which is the classification of discrete time systems. According to the classification, the discrete time systems can be classified as linear and nonlinear systems, time variant and invariant system, also called as shift variant or invariant system, linear time invariant system and linear time invariant system, causal and non-causal system, static and dynamic systems, stable and unstable systems, FIR and IIR systems, invertible and non-invertible systems. So we'll see one by one each. Linear and nonlinear system. A system is said to be linear system if it obeys superposition theorem and the homogeneity principle. If it obeys the superposition and homogeneity, we call it as a linear system. Otherwise, we call it as a nonlinear system. So, a system which produces the output y1 of n for input x1 of n and y2 of n for input x2 of n, according to the superposition theorem, y1 of n plus y2 of n should be the output for the combined input x1 of n plus x2 of n. Homogeneity principle means a system which produces an output for an input with a constant multiplication, that is a. That is the for x of n input if the output is a y of n for a input a x of n. A time variant and invariant system. The system is said to be time invariant if input-output characteristics does not change with time. In the form of equation, we can say y of n comma k if it is equal to y of n minus k, the system is time invariant. Otherwise, we call it as a time variant, where this y of n comma k is the output for the delayed input, that is replacing x of n with x of n minus k. Whatever the output we are getting, we call it as a y of n comma k, where y of n minus k is the delayed output. Simply replacing n with n minus k, we will get y of n minus k. Coming to the linear time invariant system and linear invariant system. That is, if the system is linear as well as time variant, we call it as a linear time invariant. If the system is linear and time invariant, we call it as a linear time invariant system. So combining both linearity and time invariance, this is a new classification. Coming to the causal and non-causal system. A system is said to be causal if the output of a system at any instant of time depends only on present and past values but not on future values of input. This system we call it as a causal system. In other words, the impulse response of a causal system is 0 for n less than 0. That is, h of n equal to 0 for n greater than 0. So, the causal systems are the real-time systems which are physically realizable, where the non-causal systems are not physically realizable. This is the causal and non-causal systems. Now, coming to static and dynamic system. A system is said to be static system if the output you are getting for only for the present input at that time, not on past and not on future. We call it as a static system. Dynamic system. A system is said to be dynamic or memory system if the output depends on the past inputs as well as the future inputs or past outputs. These systems are called as the dynamic systems. Coming to stable and unstable systems. An LTI system is said to be stable if it produces the bounded output for the bounded input. That is, if for some bounded input sequence x of n, the output is unbounded, then the system is unstable system. In other words, the system stability is also defined by using its impulse response denoted by h of n. So, if this impulse response is finite, that is summation n equal to minus infinity to infinity, mod of h of n is less than infinity, the system is said to be stable, otherwise it is unstable. Then FIR and IIR system. These are the two main important categories of a discrete system. FIR denotes finite impulse response and IIR denotes infinite impulse response. So if the impulse response is finite, we call it as a FIR system. If impulse response is infinite, we call it as IIR system. Then coming to the invertible and non-invertible systems. A system is said to be invertible system only if an inverse system exists when which cascaded with the original system produces output equal to the first system. And if it does not exist, we call it as a non-invertible system. See, as shown in figure, we have first a system with some transform T. Now there exists a system with a transform T inverse, which will do the same reverse operation. And in the output, we are getting the input x of n same. If it happens, we call it as an invertible system. Otherwise, we call it as a non-invertible system. So these are the classification of basic discrete systems. Thank you.